This course is a introduction to the theoretical side of math. It'll help you learn how to write proofs and generally solve problems in that sort of way. The book we're going to be using is by Ethan Bloke. I hope I'm saying his last name right. The book's called Proofs and Fundamentals, a First Course in Abstract Mathematics. I'm using the second edition. If you're not taking the class yet, or say you are in a class and you want the same similar, if you want the book that I'm using, I'll have a link down in the description to where you can get the book and be able to follow along with me exactly. And we're going to be going through the first 5 chapters in the book. The first video will cover statements, and that is in Chapter 1, Informal Logic. We'll move on from the Informal Logic chapter to Strategies for Proofs. It doesn't cover every way there is to solve proofs, but it'll cover the majority, what you're going to use almost exclusively through your undergraduate studies. It'll be direct proofs, contrapositive, contradiction, cases, if and only if, and we'll probably end up covering induction. It's in chapter 6. I didn't use it a whole lot whenever I was in my undergraduate studies, but it did come up a couple of times, so I may end up including that one. I'm still undecided on that. After we go through our strategies of proofs, we'll kind of go through the next couple of chapters, and it's all just set theory, just kind of to dip your feet into the pool of theoretical math. So chapter 3 will be over sets, then chapter 4 is over functions, which is really just studying sets some more, and chapter 5 will be relations, and then we'll have finished the first course. And hopefully you all enjoy it. If this one goes well, I plan on teaching another course. I'll probably do abstract algebra after this one. But let's go ahead and get started. So let's dive right into it. This first section is on statements. And we'll have a few keywords here that you need to keep in mind. These are just definitions as they come up. Write down the definition for it and memorize them. Make sure you know them by heart. Don't have to refer to them ever again. You want to know exactly what these mean, and you're going to need to do this for every section. So I've went ahead and highlighted them, and I'll do this for every single video. So the keywords that you're going to want to look out for in this video are statements, conditional, biconditional, negation, conjunction, and disjunction. So let's jump right in. What is a statement? Well, a statement is something that we can express verbally or written or any other way that is either true or false. So, knowing this, let's take a look at a couple examples. In our first example, it is raining outside. Is that a statement? Well, you could look outside if you wanted to. You could see if it's raining, then it is raining outside is true, and if it's not raining, then it is raining outside is false. It's something that's either true or false, therefore it is a statement. Moving on to our next example, are you reading this? Well, it's a question. It's not something that we can explicitly say is true or false, so this wouldn't be a statement. Alright, last example. Picture of a cute blue little baby. Is this a statement? No, it's just a picture, so we can't really say it's true or false, so this also is not a statement. Now, if the only thing we could do with statements is say that it's a statement or it isn't, it wouldn't be very interesting. So you're probably wondering, what's the point? What can we do with these statements that we're coming up with? Well, we can construct them into more complicated statements. And we're going to go over 5 different types of constructions. We'll jump into the first one. It's called a conjunction. Our first construction of a statement is a conjunction. And the conjunction of 2 statements, say P and Q, denoted by the following, is a statement that is said to be true if both P and Q are true. Otherwise, it's false. So we can look at the following truth table. In this truth table, what we would do is we'll set up the statement P and the statement Q. So we know a statement can be true or false. So how many different combinations would we have to where we have P or Q as true or false? It's a basic combinatorics problem. Basically, we have 2 different options for a statement, and we have 2 different statements. So it would be 2 times 2 gives us 4. So we have 4 different options, 4 different scenarios, and where we could have one being true or the other one being true. And as you can see, we have both P and Q as true, both P and Q as false, P is true and Q is false, and P is false and Q is true. So when we look at the conjunction of the two, as we said previously before in our definition, it's true only when they're both true and false otherwise. So when we have P and Q both true, you see that P and Q, the statement P and Q, is true. Where P and Q being false leads to P and Q being false, and so on. The rest of them are also false. Our next construction is called a disjunction. And this is denoted as P or Q. And it's true if either P is true or Q is true, and it's false otherwise. So if we look at the following truth table, once again, we have 2 different statements, and we're going to combine the 2. So with the 2 different statements, we have 4 different scenarios where we could have either being true or false. We have P can be true, Q can be true. We have P can be true, Q can be false. P can be false, Q can be true. Or they could both be false. And with a disjunction, you can see that so long as one of them is true, the new constructed statement is going to be true. So when P is true and Q is true, P or Q is true. If P is true but Q is false, the overall new statement P or Q is still true. It doesn't matter that one of them's false, we have one of them as true, so the whole statement's true. And then similarly, where we have Q is true and P is false, the overall statement P or Q is still true. The only time we have it as false is when we have both P and Q as false. Then P or Q is false itself. The third construction we'll look at is called a negation. And it's denoted as follows, where if P is true, then the negation of P is false. And if P is false, then the negation of P is true. Now if we look at the following truth table, it's exactly as I said. We can have P as true or false. So the negation, we have when P is true, the negation is false. And when P is false, the negation is true. The fourth construction is a conditional. A conditional from P to Q, denoted as P with a forward-facing arrow pointing to Q, is true if it is never the case that P is true but Q is false. And when we look at the truth table, it may be it's a little weird. It's kind of hard to wrap your head around, because you'll see right here we have when P is true and Q is true, the statement's true. That makes sense. And we have if P is true, if Q is false, it's false. And that kind of makes sense too. But then you have P is false and Q is true, but it's still true. And then we have if P is false and Q is false, it's still true. I understand it's a little bit weird and kind of hard to wrap your head around, but the best way probably to think about it is, imagine if you switched those last two to being false, it's the exact same truth table that you would have for a conjunction, and that'd be really redundant. There'd be no point in the conditional at that point. It's logically necessary that we have the truth table set up as it is, and this is how mathematicians do it. It's just something you kind of have to get used to. Our last construction for statements is the biconditional. It's denoted as P with double arrows in between the P and Q, and it's a statement that's true when P and Q are both true or they're both false, and otherwise it's false. So if we look at the following truth table, we can have P and Q both true, in which case the biconditional of the two will be true. If P is true and Q is false, the biconditional is false. If P is false but Q is true, the biconditional is still false. And when P is true and Q is true, when P is false and Q is false, the biconditional is still true. And that covers it for our constructions. There's two different terms that you would want to know for statements whenever you have a truth table. And the first one is a tautology. And a tautology is when your statement is always true, regardless of whether your component statements are true or false. The easiest example of this would be to take a disjunction of a statement. Let's say P and not P. If you remember the negation table for that, it was whenever P is false and then not P is true, and whenever P is true, then not P is false. So if we take a disjunction of the two, then we always have one side being true. And with a disjunction, as we had said in the definition of it, as long as one of your statements is true, the overall disjunction statement is true. So since the disjunction of P and not P is always true, regardless of whether the two are true or false, it's a tautology. And the next thing is the exact opposite. It's a contradiction. And this is when your overall statement is false, regardless of whether your component statements are true or false. And we'll just do a simple one again. Let's just say the conjunction of P and not P. Well, if you remember from the definition, conjunction is true only if both statements are true, and it's false otherwise. So whenever we make P true, not P is going to be false, so the overall thing is false. So let's make P false. Well, then not P is true, so both of them aren't true still, so the overall conjunction of the two is going to be false. And we can see that overall the conjunction of P and not P is false. Therefore, it's a contradiction. So let's do some practice truth tables. That way you can get comfortable with actually constructing them. Our first example is going to be if R, then S, if and only if R. So let's start with the basics. We have two statements here. We have R and S. So that gives us four different possibilities for true and false. We can have R is true, S is false. we can have R as true and S as true. We can have R as true and S as false, R as false, S as true, and R as false, S as false. So now that we've broken down our component statements, let's look at a bigger chunk of it. So we have if R of an S. So this is just a biconditional. So let's look at our component statements and then use our definition of a conditional, and we can figure out what the true or false is for each of these scenarios. So if you remember, the definition of a conditional stated that it's always true unless you have your initial statement as true and your conclusion as false. So we can look at this and we have R is true, S is true, so it's going to be true for your conditional. We had R is true, S is false, and that's where it's going to be false in your conditional. And then the next two, we had R is false, and it doesn't matter what S is, our conditional will automatically make those true. So for the conditional part, we have true, false, true, true. Now that we know what it looks like, our truth table looks like for this chunk, let's combine it with the rest of the table for the rest of our statement. Now we have if R of an S, if and only if R. Since we know what if R of an S looks like in the truth table, we can figure out what it is on a whole now. And so we had R was true in the first one, if R of an S was also true. So if R of an S, if and only if R, is also going to be true. For the second part, we have R as true, but we have if R of an S as false. So the overall statement is going to be false. And then we have R as false, and we have if R of an S is true. So that's going to be false as well. And then we have R as false, and if R then S as true again, so that's also going to be false. So the overall truth table for this is true, false, false, false. Alright, we're going to do one more practice problem for this section, and then we'll move on to our next section. So, if and only if F, then if and only if G. So let's start with our simple statements, the ones that were used to construct this monstrosity of a problem. So we have E, F, and G, and we know each statement can be true or false. So as far as on the whole, we have 8 different possibilities for how we could arrange each statement being true or false. Since each of them have 2 possibilities, we have 2 times 2 times 2, which is 8. So in the first one, we have all 3 of them are true. The second one, we have E, F are true, and G is false. Third, we have E is true, F is false, G is true. E is true, F is false, G is false. E false, F true, G true. E false, F false, G false. E false, F false, G true. And E false, F true, G false. So let's look at the biconditional part for E and F. Well, in our first scenario, we have them both being true. So E, if and only if F, is also true. And that's what we have on our second line, so that one's also going to be true. Now, on the third one, we have E is true, F is false. So the biconditional is going to be false. Same for the fourth and fifth one. Then when we get down to number 6, they're both false. Remember, a biconditional is also true if they're both false. So our biconditional is true here. And then the 7th one, one of them's false, one of them's true. So the biconditional is false. And then our last one is going to be true because they're both false. Now that we've got the biconditional for E and F, let's look at the biconditional for E and G. So the first one we'll have is true because E and F are, or E and G are true. The second one we'll have is false because one is true and one is false. The third one is true because they are both also true. The fourth, fifth, and sixth are going to be false because one of them is false and the other one is true. And then the last two are going to be true because we have both of them as false for both of those scenarios. Now that we have those, we can look at the statement overall. We can look at if E, if and only if F, then E, if and only if G. Now remember, for a conditional, it's only false when your hypothesis is true, but your conclusion is false. So when we could go down through here on the first one, we see that it's true. The second one is one of those scenarios where it's false. And all this column is going to be true except for the sixth one, the second and sixth one. We have the hypothesis being true and the conclusion being false, therefore the entire result is false for those two scenarios. Now that we've finished the section, I've got one more truth table that you can do. And here's the statement. I've went ahead and done the first couple of columns. That way you can provide an answer down in the description of what you have for your final truth table column for the overall statement. And if you copy it down the way I have it here, yours will be in the same order. I can tell you if you got it right or not. Also, this is the first lesson I've ever done, so feel free to ask any questions. I'll get back to you or leave a comment on how I can improve. I'd greatly appreciate it. I hope you all enjoyed it, and stay tuned for the next video.